Today we're going to be taking a look at the Bernoulli distribution in Python. We're going to be utilizing different packages such as NumPy, SciPy, as well as Matplotlib to look at generating a random Bernoulli distribution and look at graphs based around the PMF as well as the CDF. But before we jump into the Python code, I want to go over a little bit more concepts about the Bernoulli distribution and how it differs from the binomial. All right, so today we're going to be taking a look at the Bernoulli distribution. So the Bernoulli distribution represents the probability distribution of a random variable that takes on one of two outcomes. So success has a probability of P, or failure, which is a probability of 1 minus P in a single trial. Unlike the binomial distribution, which involves multiple trials, the Bernoulli distribution focuses on just one trial. You'll see this explained a little bit better on the next slide, but here are some examples, and these are going to be nearly identical to what I showed in the binomial video, but a coin flip, right? You could have either heads or tails, but we're taking a look at one specific coin flip as our trial. A new subscriber from watching a YouTube video. So this is going to be a singular view on a YouTube video, right? The user has the chance or the opportunity to subscribe or not subscribe. A pitcher throwing a strike. So in baseball, a pitcher throws a ball towards a batter and catcher. The pitch is either classified as a strike or ball, right? You have two options, strike or ball, subscribe, not subscribe, heads or tails. So terms of success is P, right? Probability one trial. So let's take a look at our new subscriber, right? Let's say there's a 2.5% probability of views turning into a subscriber. So the success would be 0.025, whereas the failure would be 0.975, which is 97.5%. Which, by the way, if you're not subscribed to the channel, make sure to do so, because I'm building out an awesome data science library of videos, and you're watching one of the statistics ones right now. So here's a few of the concepts, right? So again, difference between Bernoulli and binomial. Bernoulli is one trial of an event. Binomial outcomes multiple trials of an event. So my example is one YouTube view on a video versus 1,000 YouTube views on a video. And that makes a little more sense for you guys. So two other concepts to understand. And by the way, these are three graphs that we're going to be building out with the Python code. But PMF, which is the probability of mass function, which is the exact probability of a number of events happening. And the CDF, which is cumulative distribution function, probability of value less or equal to the number of events. So with this background information out of the way, I think we are ready to code. So let's start doing that. All right, so let's start with our imports. So import NumPy as NP from SciPy.stats, import Bernoulli, and then import Matplotlib.pyplot as PLT. Once these are run over here, our imports should be done. First thing we want to do is set a random seed for NumPy. It's np.random.seed. I'm going to put in 17 because that's what I used for my example code. And we are ready to go. So let's look at example number one. So example number one, we're going to generate a Bernoulli from NumPy. So gen Bernoulli from NumPy, and let's get started with that. So we're going to start off with P success subs equals 0.025. Then in here we're going to set our trials. So n trials subs equals 0.025. Then n trial sub, that's going to be equal to 1. And then finally, what we're going to do is size, right? And we're going to say size videos, and we could say 100 over here. And that could either be two different things for size videos. You could be taking a look at one view across 100 different videos, right? Or you could be taking a look at one view 100 times on one video. Up to you, right? And you'll see in the binomial one, if you watch that video, instead we look at 1,000 views across 100 different videos. But since our trials are one, when a Bernoulli, that's why you could typically change what you want to look at on here. Okay. what we're going to do is simulate this now. So we'll say NumPy samples equals np.random. Now you have to use binomial on this. So you set your n to equal to n trials, which literally is 1, right? And that's why we make it a Bernoulli. You set your p equal, and we have our p success over here. And then your size, lastly, size equals the size of the videos on this side of things, right? And we can print out our NumPy samples. Now, it's 2.5% probability, so hopefully around 2. And you can see no subs. We got our first sub right over there. We got our second subscriber. So now let's take a look at our second example. Example 2. We're going to do is coin flips in SciPy. Let's go forward with that. So let's start off with our success. So p success coin equals 0.5, right? Then we'll look at size coin flips equals 100. And SciPy has a Bernoulli, so we don't have to set up, as you can see above over here, right? Trials 1. We don't need to do that this time. So we'll say SciPy samples equals Bernoulli RVS p equals, and pass in success coin, size equals, pass in our size like that. Run the cell. And if we want to look at our coin flips, which they should be about equal 50-50. And when they have 100, it's probably not going to be equal 50-50, but you can see over here a good amount of 1s and 0s. First initial thoughts looking at this, seems to be a lot more 1s than 0s, but we may plot this a little bit later. And yeah, so what I want to do now is take a look at example 3. So through here, right, you should know how to generate a Bernoulli from NumPy, generate it from SciPy. Personally, SciPy is easier. 1 line less of code, right? Set your trials, but either works. So example 3, we're going to calculate PMF. So this is pretty easy. We can go our coin again, right? So we'll say p success coin equals 0.5. And then let's say PMF success coin equals, and then in over here, Bernoulli .pmf, then set our k value, k equals 1, then p equals success coin, and then you can have failure. So literally it's going to be almost identical in the code. Well, PMF value should be as well. And you just set k equal to 0 this time. Our probability is still going to be the same, right? Heads or tails. And let's print out these. So you can see the success of the coin, right? 0.5. And then our failure should also be 0.5. And rounding, right? We have 0.5. Now let's take a look at our CDF, which is the cumulative. So example 4 is our CDF, and start off with that. So what we're going to do now is take a look at the YouTube subscriber. So success, we don't need coin, but p success equals 0.025. That in here, and let's start off with our CDF as 0. So CDF is 0 equals Bernoulli .cdf. And then inside over here, we pass in 0. Then we pass in our p success. And then let's do CDF of 1. Right. And let's print these out. And I almost didn't put the CDF in the video because I kind of felt it was pointless, but regardless, I still put this in, right? The CDF is 0.975, 97.5% probability. And if you put a CDF of 1, well, it's just going to be 1. You have 100% probability. So not much there. You'll see the graph also, but you know, why not include this classic CDF over here, right? 0 or 1. And remember, CDF builds upon its that result or earlier. So when you have 1 and you have two options, 0 or 1, it's going to be 100%. All right, so let's get started with our plots. So plt.figure, and what we're going to do is set our figure size. So fig size equals 86. Then what we're going to do next is plt.hist, and then pass in our SciPy samples. So SciPy samples, set our bins equal negative 0.5, 0.5, 1.5. Then color sky blue, and then edge color here, edge color equals black. Right. Set our title, plt.title, histogram of sample data. Then plt.ylabel, or xlabel first. Put a number of successes. plt.ylabel, frequency. And then, just because I want our plot to look a little better, we'll have x ticks, pass in 0 and 1, and then plt.show. And what this will do, our SciPy data over here, so 0 and 1. If I remember correctly, our SciPy was coin flip. And you can see over here that when I mentioned that there was a lot more ones, right? That's obviously the case. You can see well over 50, whereas 0 is probably, let's say 45. We'll say 45, 0, and 55 being 1. And, you know, you could change this up. Histogram of coin flips, probably the better way to say it. And there we go. Okay. Now let's take a look at our probability mass function, and let's build that out. And we're also going to look at coin flips again with our PMF. So go PMF coin flips, and you should expect, you know, being 50-50 over here. So P success coin. Well, I've already had this built or written earlier at 0.5, but we'll repeat that again. So it's over here. We'll say x equals np.array 0 or 1, right? Our two options, heads or tails. We'll set our PMF. So PMF equals Bernoulli dot PMF, pass in x, say P equals our P success coin. That's awesome. And then let's plot our stuff out. A lot of this code's gonna be the same, so I'm literally just gonna copy this to start off. I'll change it up, right? So figure, good with that. Then I'm gonna set up a bar this time. So bar chart, we'll have x over PMF, say width 0.4, and I'm good with the color and edge color. We don't need our bins this time. And we'll say on this side is for title, PMF coin flips, and our X label, right, is gonna be number of successes. Well, you could say heads or tails, whatever, right? Heads or tails, it's gonna be the same, 0, 1. And well, actually, looking back, I had two X labels over here, didn't I? So just double check my stuff. Our second one over here should be our Y label for frequency. I apologize. I just saw that over here. I'm like, that not makes sense. Frequency, number of successes, right? 0 or 1. Okay. So let me just go back over here. Same thing, right? We could do heads or tails or number of successes. Like, pretty basic example. And then we'll have probability. And x ticks 0 or 1. Should be pretty good here. After I put a comma, this width equals 0.4. Here, PMF coin flips, right? 50, 50. Awesome. And lastly, let's take a look at the CDF of a coin flip. And pretty easy on this one. So example 7, CDF of coin flip. And we're going to take a look at this time the step plot. So again, I'm going to start off with some of this code. And we'll write sections of it. And we already have our success over here. We already have our X, which is this array. This code is going to be reused again with this X. But let's set up our CDF above. So what I'm going to say is our CDF equals Bernoulli.cdf X probability success coin. So that's good. Fig size is going to be there. Then we're going to say plt.step. Oops. Right over here with the bars. So plt.step. We'll have X. We'll have our CDF instead of PMF. Where is going to be post. So we'll say where equals post. Label CDF. F. Color. We'll give it a sky blue again. And LW2, line width. Right. We'll say CDF coin flips. Then our X label. Right. We'll have outcomes. We'll have our Y label over here. Cumulative probability. Which, did I not change this one over here? I apologize, guys. Made that mistake twice. So Y label needs to be probability. X label number of successes. Going back over here though. X label outcomes. Y cumulative probability. I'm going to go with X ticks 0, 1. Or Y ticks. We can set those up if we want. plt.y ticks np.arrange 0, 1.1 step equals 0.1. We can have our grid plt.grid, pass in our true, and this will be our code. Assuming no errors. Pretend to have errors. There we go. That color is not dark enough. I'll put color equals B. And then you can see the CDF has been plotted. It's better when I put color equals B instead of that sky blue. But you can see, right, cumulative probability in the beginning, right, for failure, 0.5, and then 1, since it includes also 0, we have 100%. So this would be heads or tails, and this one over here would be, for example, tails. So that's Bernoulli. Just remember on Bernoulli, right, we have one trial. Rather, with a binomial, you're going to have greater than one trial. I showed you an example of YouTube subscribers. We did that with NumPy. Then we went to SciPy for coin flips. Took a look at the PMF, right, which is the probability of a distinct outcome. Again, heads or tails, 0.5 for either side. Then we went over a CDF example with YouTube subscribers. And remember, CDF is cumulative. So in the beginning, 97.5% probability not being a subscriber. And then once we added in the CDF of 1, which is non-subscribers and subscribers, you get to 100%. And then showed a few different graphs. We had a histogram of coin flips, right? Frequency, success 0 or 1. Then we looked at the PMF. Again, we went over that a little bit earlier in the code, but 0.5, 0.5. And lastly, the CDF of coin flips 0.5 and then 1. Hope you guys enjoyed this video on the Bernoulli distribution, and hopefully you understand the differences now between that and the binomial. If you did, make sure to subscribe to the channel. One of our goals here is to reach 100,000 subscribers in 2025. And the only way we do that is by making high quality data science videos every single week. Now, if you want to learn even more statistics concepts, I have a few videos linked down below in the description and a playlist that you can check out right over here.